Warning! Tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, got the KT120 dialed in. Maybe not 100%, but getting close. Close enough to start doing some testing on it, show you where we're at, and I really feel like now we're ready to move into step 2, which is building the second monoblock. There may be some further small tweaks that we end up doing, but we're talking about maybe a couple of resistors or maybe some different input tubes. But for right now, we're going to test this thing with a 6EJ7 with the couple of small changes that I made from the initial schematic that was kind of the draft of what this amp was going to be. And like I told you in an earlier video, the iron solid, none of that's going to be changing. Maybe, like I said, a couple of small tweaks to some resistors and stuff to eke a little more power out of it. But as you're going to see, this thing's a monster. So let me show you the changes I made to the schematic, and then we'll jump right into doing some THD versus power pulls on this thing, along with the frequency response, etc., and show you what this thing is. Okay, so this is the original schematic that I drew up as a starting point, and some of these things I was just kind of guessing it, or not guessing, but a best guess, let's say, of where these components needed to be as far as the values. And even on Kager's schematic, he had kind of a range. Plus, we're doing a fixed bias instead of a cathode bias like he did, so some things were obviously going to be different. And this is kind of where I thought we would be. And we ended up getting slightly different output transformers than I was thinking we were going to be using. They're 4.3K instead of 5K, which isn't a huge deal. We were using the 6EJ7 to start with, although we can roll a bunch of different tubes in. I was thinking I might use a little less of the shade feedback and go with a higher value resistor here. And the mistake I made here was putting a 100K resistor for the grid leak resistor going to the negative bias when the spec sheet says 51K is the max. And so we had to change that. Put the amp together. It had a little bit of asymmetrical clipping when you started turning the volume up. And then it also had a little more distortion than I wanted to see. So let me show you the changes that we made. And here's the version that we have right now. And I'm calling this version 2. So one of the things that I wanted to do was to hit this 220 volts on the plate of the 6EJ7. And initially this voltage was almost 500 volts. And so we increased the value of this decoupling resistor to a 3.6K, and that brought this down to 470. Ideally, I'd like to see this at like 235 to be splitting the difference between the two sides of the tube, but 220 volts seemed to work just fine. We got there by raising the value of this resistor, and that brought our bias point up to 3.8 volts from 3 volts. So because we have our LED right here that's dropping approximately 1.6 to 1.7 volts. And that again got this up to 220 originally with the 150 ohm resistor. This was down about 180, I think, or 190 volts, which I knew was too low. So we biased this a little colder, got this voltage up a little higher, and that got rid of the asymmetrical clipping that I was seeing. As you can see here, we corrected this grid leak resistor, made it 51K, which is what the tube says you need to have to prevent thermal runaway. And those are really the main tweaks. Oh, and then we went to 150K on the shade feedback resistor, which is what Kager initially had spec for this to be. And all these changes definitely worked. We ended up with 495 volts on the output transformer, the B plus coming out of the power supply. We got 475 on the plate, which means we've got 475 across the tube because the cathode of the tube is basically grounded. It's running through this 10 ohm resistor, so we can measure the milliamps across the tube, which will be directly measured at this test point in millivolts. And it seems to like running pretty hot, and I'll show you in the next segment where we ended up with the bias point and the output power at the two different bias points. But like most single-ended ultralinear output transformer type single-ended amps, the tubes really do like being run pretty hot. So anyway, let's get this thing on the audio analyzer suite and show you what this thing's putting out. Okay, so we have the KT120 monoblock hooked up to our audio analyzer suite, and like I talked about in the first segment, there were a couple of minor adjustments I needed to make to the setup. One was that I had the driver tube initially biased a little too hot. That was causing some asymmetrical clipping up at the top end. And I also went to the shade feedback resistor that Kager suggested, which was 150K. And I do have to sit down and listen to this amp and see what it sounds like with different amounts of feedback resistance, because I have found that that can impact the tonal qualities. And I haven't even started to try different front end tubes. This is just a triode strapped 6EJ7 like I was going to originally start with. And I know that there's some other tubes that'll drop right into this pinout in this bias setting that gives a variety of different sounds from this amplifier. Plus, as you'll see here, with the fixed bias, we can adjust where the output tube's running and impact the output power as well. So this first run is going to be at a really cool bias point, something that's, to me, super safe. It's 100 milliamps at 470 volts on the plate, which equates to about 80% of the dissipation that this tube can handle, which this tube would last for years like this. So let's take a look at what kind of power versus THD we get off this setup. And as you can see, the distortion is down here way below 0.1%. Does this little jump right here, but not a big concern. We're at 2 watts and we're still at 0.2%. Looks like kind of crossover, 1% distortion, about 8 watts. Yeah, 7.5 watts, we got 1% distortion. Right here where I kind of consider being high for a tube amp, which is, you've seen me say this many times before, about 2% is where I kind of draw the line. We got 14.8 watts, which is exactly what I was shooting for with this amp. And this is with it biased super cold. So we hit the benchmark without even having to crank the tube up. But I found, especially with these ultralinear type amplifiers, they really like being biased pretty hot. And I found that I can turn this one up to about 114 milliamps, and that puts us at about 90% dissipation. It brings the voltage down a little bit on the plate to get us to that 90%. So here we are at 114 milliamps. And let's see what this thing does here. Again, we're staying down below 0.1% distortion. And right there it starts rising up, but we're making several watts of power, and we're still below 0.5% distortion. As you can see, the curve kind of flattens out at this higher dissipation. And here we are, 10 watts at 1% distortion. And then we go up here to our 2-watt limit, and this is about where you can see the distortion turns up right here. And this is about where it's maxed out. It's making 18 watts of power out of a single-ended amp. Guys, I'm impressed. And down here at these lower wattage levels, where I'm going to be listening to most of the time with my efficient speakers, at 2 watts we have 0.25% distortion. We have less than 0.5%, way less than 0.4% at 3 watts. It's making 4 watts at 0.5% distortion. This far exceeds my expectations of what this amp was going to do. And I've just gotten started with tube rolling and doing any serious tweaks on this thing. Guys, I'm seriously blown away seeing these results. So I haven't done a frequency response pull yet. So let's see what this thing does. And we'll just do this at the default settings. And this is already looking good for it to start off this high up on the dB chart. What a beautiful frequency response curve. Because right here, we're at 0 dBs. Down here at 20 hertz, it's rolled off 0.25 dB. And the same thing at 10K, it's still flat. I mean, it peaks a little bit right in here. It's up about 0.1 dB in this 1K to 10K range. And then at 15K, we've got 0.25 dB roll off. And then at 20K, we've got 0.7 dB. And then it falls off a cliff, which is what we want it to do. So we don't have issues with oscillation. So the next test we want to do is the THD versus frequency. And this will show us the spectrum analysis, and it'll also give us a good idea of how good these output transformers are, because in my experience, good output transformers have low distortion at low megahertz or low hertz. And we've got 1% distortion at 20 hertz. Now we're measuring this at 1 watt of power, which is my default measuring point and the default for this software. We can do another pull at a little higher power level and see what that looks like. But I'm looking at these harmonic distortion analysis down here, and this looks beautiful. Actually, I'm going to stop this because this is a higher power amplifier. Let's do this pull at 5 watts and take a look at what it looks like. I'm still seeing very low distortion levels at 20 hertz compared to a lot of amplifiers I've tested. And the other thing to remember, guys, these are not like $1,000, $1,200 a piece output transformers. These are still what I would consider, budget output transformers. And they're performing very well. And in my opinion, the distortion that they have, or an amp might have below 100 hertz, you're really not going to hear that. As long as they flatten out around 100 hertz, they're doing a good job. And that's exactly what these are doing. And here we go. This is a really nice THD versus frequency, especially for pulling this at 5 watts. I mean, it's flat from 100 hertz up to the end of the frequency range. It does have a little dip here on the top end as far as the THD, not sure what that's about, but the key thing to note is here where the THD takes this dip, we're at 6K, and if we look at the frequency response at 6K, it hasn't lost any power. So if anything, it'll just make the top end of the frequency range sound a little crisper. So, time to go listen to this thing. I need to hook this thing up to my system. Probably going to run it at the lower bias point to start with and just kind of let the amp break in some. I probably am going to wait on installing that WEMA film cap and some other stuff just to see how this thing works with the components that I built it with, and then come back and swap that cap out, do some measurements and see if there's any difference doing that. But I think we're ready to build the second one and show you how to make these things yourself. So this looks like a great place to wrap up this video. Well, like I said in the video, this far exceeds my expectations. I mean, I knew this thing was going to be pretty good, and I've done some designs following Kegger's kind of inspiration on some other amps, and I've used this ultralinear with shade feedback setup on some other pentode amps like my 47 amp, and I built one of those blue glow type KT88 amps, but this is like next level. I mean, I'm almost shocked at how good this thing turned out. I listened to it for about 45 minutes today. Obviously, that's not enough to really break in an amp like this. You know, things need to like settle down. But I can tell already this thing sounds really awesome, just having one channel. And obviously, when you're used to listening to stereo, when you're listening to just one channel of a stereo recording, it can kind of sound funky, you know, so I'm trying to keep that in the back of my mind, but I can hear the detail, and I can hear the bass, and I can hear just the cleanliness of it. It just really sounds sweet without being like clinically harsh like some solid state amps can be. And this thing's got so much more power than any of my other single-ended amps, it's not even funny. Now, I do need to work on putting together a really nice preamp to drive these with, and these are going to run so clean, I think my color preamp might really work well with this to be able to add a little bit of harmonic distortion to give it some warmth if I feel it needs it. And I can dial that in like I showed you on that preamp build. And so I think that would be an awesome partner with these monoblocks, given that these are just strict power amps. Now, one of the things that I am going to tell you guys, on the choke that I used in here, I had some of these just laying around from a previous project, or I'd bought for a project that I didn't end up using. And so I used one of these 157R Hammond chokes. Now, when I looked on Hammond's site, they say that the max DC voltage is 400 volts for this choke. But the thing that seemed kind of weird is they're saying the insulation on the bobbin and the windings and stuff is good for, or they're tested at 1500 volts AC. And when I compared this to some of their chokes, like this one sitting here in the back that's got the end bells on it, they had another 100 to 200 volts of rating when they put end bells on the same size choke. So I'm thinking that they're downrating this because of it being an open coil or an open frame choke like this, and they're not sure if people are going to like put them on top of an amp and where people could touch them with their fingers. And so I'm not too worried about them being rated at 400 volts. If you are concerned about that, you can step up to this guy, which is the 159V. It's a 1.5 Henry at 500 milliamps, which is super overkill. It's rated for 500 volts, which is really close to what you're going to see on the B plus rail of this amp. And if it'll make you feel safer, that one is rated for the voltage, but I'm not concerned about this. And I started thinking through the whole scenario, and the worst case is if this can't deal with the extra 100 volts, it would just, internally arc short something and blow the fuse, and then I'd know that I've got a problem and would come back and replace it with this. I've already drilled the holes. I've already kind of laid out the amp to use this size choke. And so trying to fit one of these in it at this point, I would have to move so much stuff around and drill more holes, and I don't want to ruin these chassis. So just a heads up, if you're building this for yourself, I'm going to put both of these chokes in the BOM, and you can decide, for double safety, get this 159V. It's rated for the voltage that this power supply has, but for my own personal one, I'm going to wing it with this one that I've already put in there and not worry about it. So anyway, I just wanted to put that in there too. Going to try to put a BOM together soon with these parts. I want to touch base with the Thermactic Labs people, or Thermactic Labs, I can't always pronounce it wrong. Anyway, I'm going to get with the guys that make this iron, see if they've put together a kit with the power transformers and the chokes and everything, and make sure that they've hit all these voltages right for you guys to be able to buy like a package of iron from them. Again, they gave me a pair of these output transformers, but I'm not making anything off of you buying the iron from them. Hammond makes some similar iron. Don't know what it would perform like in this amp, but it would probably be fine. Edcore makes, iron sort of like this too. I've had good luck with Edcore iron. So anyway, this amp, we are showcasing this manufacturer's output transformers. And so far, looking at the numbers, I'm impressed. And I think they're doing a really good job. And I'm happy to see someone new, or relatively new, getting into this tube amp iron market, because there's so many people that were winding stuff like Jack at Electroprint. He went out of business, retired. There's several other, Transcender, no longer making iron. And so there's so many of these companies that are going out of business. We need to embrace these folks that are starting out and trying to make a business out of this thing and show them our support. So anyway, here's the other chassis. Got the tubes laid out in it. I used this top plate and just flipped it over to make a mirror of the layout. So these will absolutely mirror each other, which I think is going to be cool. And going to get busy building on this thing. On the second one, I'm absolutely going to do this in a step-by-step video series and show you how to build the second one that's just like this one, because now I know that everything fits and is in the right place and all that stuff. Again, I'm probably going to just go with this smaller choke. I've looked in here. I could re-drill and put this big guy in there, but I have to go buy another one. And if I end up having to, I can retrofit this in here. But I've got 4 of these and I want to use them up. So we're going to take a chance on it and hope that those work. I still haven't tried KT88s in this thing. I'm hoping that I can change the rectifier tube to like a GZ37 that's got a lot more voltage drop across it and be able to put EL34s in this thing. But that's for experimenting later. Like I said, I've got about 4 different kinds of driver tubes that'll drop in this amp. I'll put a sheet on the website that shows all of the tubes that you can drop into this position in the amp that use the same pin out if you try to strap it like this one is. And so, this is just cool stuff, I think. And again, I don't want to belabor the point, but while I know people like watching me try to fix these made in China amps, this is the stuff that I really love. And especially when it turns out like this, and it's just knocking it out of the park with numbers like I'm seeing. I mean, I know some people might say, 2% distortion is ridiculous, but I know that 2% distortion on a tube amp does not sound bad, and I can see where it starts clipping right there at 18 watts, which is insane for a single-ended tube amp. And given my use for it, I'm never going to be using it anywhere near even 1% distortion. And so this is going to be a really fun pair of amplifiers. So anyway, and then I also want to show you, I did get some of these film caps, some WEMA little box caps that are 30 UF 600 volts that we're probably going to put in here for the decoupling network. That's that 3.6K resistor with the 33 UF cap. Going to put a pair of these in here because the amp does go up to about probably 560 volts before the tubes start drawing down. And I'm more concerned about those electrolytic caps getting overvolted than I am this choke. So this is going to be an upgrade we're going to do to it too. I'll put this in the bomb. So anyway, I hope you're enjoying this series and the continuation of it. I think the next part of it's going to be fun too. Show you how to do the fab work and how we're laying everything out inside. I think, people that build these, you're going to love them. I mean, obviously, I need to get the second one finished and then hook them up as a stereo pair and, spend some time with them. But I'm pretty sure these are going to be some serious good amplifiers. So anyway, if you're enjoying this content, please subscribe to the channel. Please like the video. Thank you all you Patreon folks and also folks that make donations. And until the next video, have a nice day.